Hello everyone, once again a warm greetings to all of you. So today we are going to start our lecture number 6 of chapter 5 electricity grade 9, and the topic related to this chapter is combination of resistors. So I hope that all of you are doing excellent in your studies, and let's begin our lesson by resistors, combination of resistors. So basically what is resistor? A resistor is a conductor having certain resistance. Each resistor has a fixed value of resistance. Keep in mind that nearly every electronic device, whether it is a bulb, whether it is a laptop, mobile phone, fan, any electronic device, they have resistors inside it. So in laboratory we have separate resistor for it in order to do different sort of experiment. But resistor symbol used for the resistor is this. You can either use any of the symbol for it, and I told you earlier that resistors are of different types. So I told you earlier that this type of resistor is used in electronic device, and this type of variable resistors are used in at physics lab, and non-linear resistor, you can see this resistor at it can be observed in street lights for lighting purpose. So there are two basic types of combination of resistors. One is series combination or series arrangement, and parallel combination. Like I told you before that the circuit combination is of two types, that is series and parallel. In the same ways, resistors can be combined in two different ways, that is series and parallel. And definitely this series combination of resistor will have effect on the voltage, resistance and current. So this combination of resistors will have effect on these three values of the components. So let's begin with the series combination of resistors. You can see over here that all the resistors, if they are connect from end point, if the end point of one resistor is connected to the starting point of another, so this resistor connected in a series manner, side by side. So then the effective resistance of the combination is equal to the sum of the resistance of individual resistors. So the total resistance is equal to the sum of all the individual resistors. That is, our total resistance is equal to R1 plus R2 plus R3 and so on. And keep in mind that the total resistance of these resistors is equal, the total resistance would be greater than the resistance of each resistor. I repeat that as the total resistance is where the value of the total resistance would be greater than the individual resistance of each resistor. In this type of combination, the potential difference across the combination of resistor is divided among the resistor. The potential difference is not the same, but the current is the same. So hence the resistors in this type of act as dividers of potential difference. So the total potential difference would be equal to the sum of the potential difference of each resistor. Same current flows through each conductor. Keep in mind, same current is flowing through each resistor. Parallel combination of resistors, on the other hand, each resistor is separately connected with the battery or voltage. So here again, that if we connect a resistor in this way, in a parallel way, the starting point of two or more resistors are joined together, and similarly their endpoints are joined together. Their endpoints are joined together. They have starting and end point, they are same. In this case, the reciprocal of the effective or net resistor of the combination is equal to the sum of the reciprocals of the resistance of the individual resistor. Mean to say that net resistance, we can have this formula for calculating the net resistance, total resistance. So 1 over total resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. Keep in mind that total resistance of the combination, is less than each individual resistance. I repeat that the total resistance of a parallel resistance is less than each individual resistance. In this type of combination, the potential difference across all the resistors is equal. Same potential difference will flow. All the resistors will have same value of potential difference, but the current will not be the same. Each resistor would have different current. So this type of combination are useful for the situation that require a low value of resistance than the individual resistance of the given resistor. So this is most at home, at school, or at local areas. This type of combination is being done, parallel combination. Why? Because if single component is removed, if a single resistor is removed, the current will not stop flowing in the circuit. So it is more useful practically. The parallel combination is more useful. So let's do some question. There are two circuits are given. So you need to find the effective resistance. Effective resistance means total resistance in the figure. So from A to B and from C to D. So let's total resistance of series. Since these three resistors they are connected in series, so the total resistance would be equal to the sum of all these three, that is R1 plus R2 plus R3. So it would be equal 3 plus 6 is equal to 15 ohm. So here you can see that 15 ohm, this value, is greater than each individual resistance. The total resistance of parallel combination. So here three resistors are given, 6, 6 and 3. So putting the value in the equation and doing proper calculation, we get the value of the net resistance to be 3 ohm over 2, which is equal to 1.5. So this total resistance of the parallel resistance is less than each individual. So 1.5 is less than 6, then 6, then 3. So the total resistance of total resistance, the total value of the resistance in a parallel combination is less than each individual value. So calculate the effective resistance between A and B in figure. Very simple. You need to find the total resistance. Both the resistors are connected in parallel. So just put the value in the equation and doing proper calculation, we get the total resistance of the parallel combination to be 2 ohm. So this 2 ohm is less than 4. Now here again find the combined resistance of the resistors given in the figure. So there are two resistors connected in parallel, and these two parallel resistors again they are connected in series with one of the single resistor. So first you need to find the total resistor of this combination, and then after finding the total resistance of this parallel combination you need to add the value with that of the 6 ohm. So first we need to find the total resistance of our parallel resistors through this equation. Put the value, take the LCM, and 1 over total resistance is equal to 2 over 3. So after cross multiplication, we get the value of total resistance to be 1.5 ohm. So we need to add this 1.5 ohm with 6. So now we can find the total resistance by adding up the net parallel resistance with that of the series one. This one is in series with this parallel combination. So add the value, so the final value comes out to be 7.5 ohm. So I hope that you have understood the lesson. Do study, do practice the questions, and stay happy and take care of yourself.